Hi everyone, my name is Amitesh, and in this video we're going to talk about solving equations with the absolute value. The absolute value is something that comes up a lot, and once you know how to solve equations, the natural thing then if you're studying the absolute value is what happens if you put the absolute value in there. How do you then solve the equation that way? So what we're going to do in this video is to consider a few elementary examples of solving equations which are linear equations with the absolute value to give you a feel for how it works. And once you master it, the general principles are the same everywhere. So in math, it's always about focusing on the general principles. And we're going to do that in this video. Okay, so let's start off with this. So solving equations with the absolute value. Solving equations with the absolute value. Okay, so that's going to be the topic. Now, how do we do this? So let's start off with the first question. To warm up, absolute value of x equals to 4, solve for x. Okay, so warming up, focusing on the basic principles, we'll keep seeing them. So absolute value of x equals 4, the absolute value of something is its distance to 0 on the number line. So when we say the absolute value of x is 4, we're saying that x is 4 away from 0. It could be 4 away on the right, so it could be plus 4, or it could be 4 away on the left, which is minus 4. So that's all there is to this. That's basically the solution is x is equal to plus or minus 4. Okay, so that's all there is to that question. But the principle here is important about the distance. So thinking about absolute value of x equals something is x is going to equal to plus or minus that something. And that's going to be the same principle we'll keep using. Okay, so that's question 1. Now question 2, okay, I'm going to switch to a black pen. Question 2 is the absolute value of 2x plus 3 is equal to 5. Solve for x. So it's always good to break things down. Whenever a math problem gets complicated, just think about the basic principles and that will guide you. So absolute value of 2x plus 3 equals 5. What is the absolute value? It's the distance to 0. So that means that 2x plus 3 is 5 away from 0. It's either plus 5 or minus 5. You can even bypass the whole distance thing if you like. I just say that for intuition. But you just know that when the absolute value of something is 5, that means that that thing has to be minus 5 or plus 5. So now we know that that means that, that's the same as saying that 2x plus 3 is equal to 5 or 2x plus 3 is equal to minus 5. So actually there are 2 equations to solve now. Solution to each of these equations is going to give us the 2 solutions to this equation. Just like problem 1 had 2 solutions, problem 2 will also have 2 solutions with the absolute value. So the first equation, 2x plus 3 is equal to 5. We can simply, subtract 3 from both sides, and we're just going to get 2x is equal to 2, which is the same as saying that x is equal to 1. Okay, so that's solution number 1. The other equation, 2x plus 3 equals minus 5, 2x plus 3 equals minus 5, it's going to be the same as saying that 2x is equal to minus 5 minus 3, which is minus 8. So subtract 3 on both sides. And that's the same as saying that x is equal to minus 4. So therefore the solutions are x is equal to 1 or x is equal to minus 4. Okay, so that's there. So I wouldn't say, for example, x equals 1 and x equals minus 4. Somehow they can't both be true. So it's either this is a solution or this is a solution. And this is a solution to the problem absolute value 2x plus 3 equals to 5. Solve for x. Okay, so far, this is a feature that we have to solve these 2 equations, and it's pretty cool that saying something like this, which is 1 equation, is actually 2 equations. I mean, how cool is that? It's like a new notation, and it does that. So let's now get to the next problem. So I'm going to ask you a question. I want you to pause the video and think about it just briefly. It's actually a very quick question. You don't have to do, you may not have to do much calculation. Okay, so let's see. So the question is the following. absolute value of 3x minus 9 is equal to negative 3. Solve for x. Okay, so that's the question. Pause the video, think about it. All right, so assume you paused it. How do we look at this? So one natural thing to do is to just go through the same process. A common error that some people might make is just to say that, okay, this is the same, and I'm going to put this in red. This is the same as saying that 3x minus 9 is equal to minus 3, or 3x minus 9 is equal to plus 3. Somehow mechanically going through the process, and this is wrong. And the reason it's wrong is because, it's wrong because the absolute value of a number can never be negative. So this is something to always think about in math. Many times in problems, you just want to think conceptually about things so that you don't make this kind of mistake. Conceptually, the absolute value can never be negative because it's a distance to 0. So this has no solutions. So the answer to this problem is that there are no solutions for x. Sometimes equations do not have solutions, and this is one of them. Okay, so no solutions there. All right, so we've done that. Now let's amp up the difficulty slightly and consider another absolute value problem. So I'm going to kind of write this out, and I want you to think about, so one thing which is good idea in these videos is try to solve the question before I answer. You can always pause it because it's on YouTube, and that might give you, even if you do it, that's great, and if you get stuck, it's more instructive when you listen to the solution afterwards. So here the next question is, so this is problem 4. I'm going to write it here. Problem 4 is the absolute value of, let's say, 2x plus 3 is equal to 3x plus 8. Okay, solve for x. The absolute value of 2x plus 3 is equal to 3x plus 8. Solve for x. Okay, so you'll notice that even though the problems are getting more and more complicated slightly, the principles are always the same. When you say the absolute value of 2x plus 3 is equal to 3x plus 8, you're basically saying that 2x plus 3 is either equal to 3x plus 8, or 2x plus 3 is the negative of 3x plus 8, right? So that's what it means to be that for you to say the absolute value of 2x plus 3 is 3x plus 8. So I'm going to say that either 2x plus 3 is equal to 3x plus 8, or 2x plus 3 is equal to the negative of 3x plus 8, which is the negative of 3x plus 8, sorry, I should erase that. The negative of 3x plus 8 is just going to be equal to negative 3x minus negative 8. Okay, so that's what the negative 3x plus 8 is. So let's write it out. So for the first equation, we get 2x plus 3. And here, like one thing to point out is we're just sticking to principles. You don't have to actually think about, what 2x plus 3 or 3x plus 8 is. Earlier when you say absolute value x is 5, it's x is plus minus 5. You can sort of visualize it. It's okay if you can't visualize it here. You don't have to. You just want to stick to the same principles. So 2x plus 3 equals to 3x plus 8. So therefore, if we bring the x's to one side, so subtract 2x from both sides and put the 8 to the other side, we're going to get that negative 5. So maybe I'll do this in 2 steps just to show you. So we get that 2x plus 3, so we get 3 minus 8 is equal to 3x minus 2x. And that's the same as saying that negative 5 is equal to x. Okay, so that's going to be one solution. Negative 5 is equal to x. Now, there is one thing here which I'll bring out. Okay, so we haven't yet solved the problem. I'm just solving this one equation, and we'll talk about this later. The other possibility is that 2x plus 3 is equal to negative 3x minus 8. Okay, so 2x plus 3 is negative 3x minus 8. Now, again, we can solve this. We can bring the plus 3x to one side. So we're going to get 5x is going to equal to minus 8 minus 3, which is minus 11. So I'm just going to, I mean, I won't show the steps there, but that's what it is. And then 5x is equal to minus 11, so x is equal to minus 11 over 5. All right, so we've got those two solutions. Now, this is an important point, okay, and this is a point that I'm going to bring up, is we have to ask ourselves, are these really solutions? Like if I go back to the equation, the original equation, and plug these in, do they work? Just as a check, as a mental check to see what's happening. So when x is equal to minus 5, 3x plus 8, right, 3x plus 8 is going to be minus 15 plus 8, which is minus 7. And this is the interesting thing, minus 7 cannot be the absolute value of anything. So actually in this case, this is not a solution. So this is something you have to do. You have to just go and check when you split it up in this way, just go and double check that it really is a solution. So here, this is not a solution. So I'm going to cancel this off. This is not a solution. On the other hand, if I take, so, but it is true, right? If I plug in minus 5, I'm going to get minus 7. Absolute value of minus 7 is 7. And this is going to be equal to minus 7. So I'm just going to get the signs a little mixed up in that case. So that's why it's not a solution. But if I take x is equal to minus 11 over 5, then I can plug it into this equation and just check. And let's do that. So I'm just going to erase this here. So if we take x is equal to minus 5, or minus 11 over 5, so plug in x equals minus 11 over 5, then we're going to get absolute value of 2x plus 3 is equal to absolute value of minus 22 over 5 plus 3, which is equal to the absolute value of, maybe I'll do it on this line, absolute value of, this is going to be 15 over 5, so it's going to be minus 22 plus 15 over 5, which is going to be the absolute value of 7 over 5, which is going to equal to 7 over 5. And then on the other side, for 3x plus 8, you're going to get 3 times minus 11 over 5. Okay, so 3x plus 8 is going to equal to 3 times minus 11 over 5 plus 8, which is going to equal to minus 33 over 5 plus 40 over 5, which is also going to equal to 7 over 5. So therefore, that is a valid solution. So x equals minus 11 over 5 is a valid solution. This is a tick, and I'm going to put it with a green tick. Okay, so this was a subtlety in the problem which is important to kind of keep in mind with these questions, that we always just have to double check that it is a solution, because when you say something like absolute value 2x plus 3 is equal to 3x plus 8, and then split it up into these two pieces, it is important to note the absolute value is non-negative. So that part has to be satisfied. Okay, so that's one solution to this problem, that x equals minus 11 over 5. All right, so I'm going to do one more question like this. So let me erase this all out. Okay. So the next question, I'm just going to amp up the difficulty one last time, and we're going to consider the following. We're going to consider problem 5, which is that the absolute value of x plus 4 is equal to the absolute value of x plus 2. Okay, solve for x. All right, so absolute value of x plus 4 equals absolute value of x plus 2, solve for x. So again, it's, even though there's an absolute value on both sides, there is the same principle here. The principle is that x plus 4 and x plus 2 are both the same distance away from 0. So that means they must be equal to each other or negatives of each other. Okay, so this is going to imply that x plus 4 is equal to x plus 2, or x plus 4 equals to negative x plus 2. which is negative x, and I'm going to rub this off too just to, yeah, it's going to be negative x minus negative 2. Okay, so this is going to be negative x minus negative 2. Okay, so let's look at the equations and see if there are solutions or not. There may or may not be solutions. So x plus 4 equals x plus 2. Well, x plus 4 equals x plus 2. If we cancel the x on both sides, subtract x from both sides, we get 4 equals 2, which is obviously an absurdity. So there is no x there. Okay, so that's not number one. Number two is for this equation, x plus 4 equals to negative x minus negative or minus 2. That's the same as saying that 2x, if I add x to both sides, I'm going to get 2x on the left is equal to minus 2 minus 4, which is minus 6, right? And that's going to be the same as saying that x is equal to negative 3. Now we've got the negative 3. Let's actually check that this works. So plug in negative 3 to both sides of the original equation. So we get, so let's do that. So just as a check, this is a check is that the absolute value of x plus 4, if x is negative 3, the absolute value of x plus 4 is absolute value of 1. Negative 3 plus 4 is 1, which is 1. And the absolute value of x plus 2 is going to equal to the absolute value of minus 1, which is also 1. So in this case, we get 1 and 1 are both fine, and therefore that's fine. Okay, so that's a valid solution. Actually, in this case, we didn't even have to check, knowing that there's an absolute value on both sides. If we know that they're negatives of each other, that's the same as saying the absolute values are equal. In the previous example, the problem was that we had the absolute value on one side but not on the other side, so it wasn't exactly the same as saying that one is equal to the other or one is a negative of the other. If in the previous problem we had an absolute value on both sides, both the solutions we found would have been valid solutions like here. Okay, so it's worth thinking about that conceptually. Of course, if you have any questions, please feel free to leave a comment down below. Happy to try my best to answer. I'll do my best to answer as many comments as possible and definitely read every single comment. All right, so these are some good examples. One last example we can do, which is kind of similar to previous examples. I encourage this to kind of like maybe a little bit harder, maybe one rung harder. So I'm just going to put this here. So let's say this is problem 5. The absolute value of 2 times the absolute value of x minus 4 is equal to, let's say, 5x, let's say 5x plus 10. Okay, so I'm coming up with these problems on the fly, by the way. I haven't actually pre-prepared them. So yeah, I'm also working it out as you're going along. So 2 absolute value x minus 4 equals 5x plus 10. How do we solve this problem? Okay, so again, just think about the basic principles. So the basic principles are that if the absolute value of something is 5x plus 10, that implies that that thing has the same distance to 0 as 5x plus 10. So it's either 5x plus 10 or it's minus 5x plus 10. But then we have to double check that the solutions we get really are solutions, because when you plug in, the right hand side has to be a non-negative number. Okay, so let's try this. So we say that 2 absolute value x minus 4 is equal to 5x plus 10, or 2 absolute value x minus 4 is equal to negative 5x plus 10. Okay, so this is going to get a little bit dicey, because we're going to have to deal with another absolute value now. Okay, so 2 absolute value x minus 4 equals 5x plus 10. So that's going to be one thing. And then 2 absolute value x minus 4 is minus 5x plus 10. Okay, so the first one, we know that absolute value x is either going to be x or minus x. So we're going to split that up. We're going to do this one by one. So I'm going to first consider this equation. So I'm going to use a bullet blue pen. So I'm going to first consider this one. Okay, so I'm going to write 2 absolute value x minus 4 equals 5x plus 10. And we have to double check our solutions here again once we get them. Okay, so 2 absolute value x minus 4 equals 5x plus 10. That implies that 2x minus 4 equals 5x plus 10, or 2x or minus 2x minus 4 equals 5x plus 10. Okay, so I'm either saying the absolute value of x is either x or minus x depending on whether x is positive or negative. Now we can solve each equation. So we say that either this implies that 3x is equal to minus 14, which implies that x is minus 14 over 3. And this one implies, if you put that on that side, this implies that 7x is equal to minus 14, which implies that x is equal to minus 2. Okay, so those are the two proposed solutions. Now it's important to mention that when x is minus 14 over 3, the absolute value of x is going to be negative x. So in this case, this substitution saying absolute value of x is x was not valid. So this was an equation that if x was positive, it would be this equation. If x was negative, it would be this equation. So because x is not positive here, we're not going to get a valid solution there. And because x is negative here, we will get a valid solution here. So x equals minus 2 is a potential solution of this equation. And then we have to plug it back into the original equation to double check. So if we have x equals minus 2, then if we plug it into that as a sanity check, if x is minus 2, then we're going to get this side, LHS, left hand side, is equal to absolute value minus 2 is 2, so it's going to be 4 minus 4, which is 0, and 5x plus 10 is going to be the right hand side, which is also going to be 0. 5 times minus 2 plus 10, which is 0. So LHS is going to be 0, and that's going to equal to the RHS. So that is a valid solution. So x equals minus 2 is a valid solution to this equation. Okay. All right. So that's one. Now the other one is we have to consider 2 absolute value x minus 4 is negative 5x plus 10, and we have to do the same thing. So I'm just going to erase this here. Okay, so I'm going to now consider this equation, and I'm going to do it in a green pen. So we're going to do this in a green pen. Green's a little bit light, maybe not so easy to read. So let me know, how you feel in the comments down below. I'll just do this in black, but I'll highlight that in green. So 2 absolute value x minus 4 equals negative 5x plus 10. Okay, so x equals minus 2 was one solution. At least we should remember that. X equals minus 2 is one solution. So here we've got this. So now again, absolute value x is either x or minus x. So that implies that it's 2x minus 4 equals negative 5x minus 10, or it is minus 2x minus 4 equals negative 5x minus 10. So this equation, if x is at least 0, this equation if x is negative, then when we get our solution, we can double check if that's really true. So in this case, we're going to get, when 2x minus 4 is minus 5x minus 10, we're going to get 7x is equal to, so minus 5x comes that side, 7x is going to equal to minus 6, which implies that x is going to equal to minus 6 over 7. So again, that cannot be a solution, because for this equation, we are assuming x is at least 0. That's when absolute value x is x. And here x is negative, so this is not going to be a solution to this equation. On the other hand, on this side, we're going to get 5x minus 2x. We're going to get, on this side, we're going to get minus 4 plus 10, which is going to be 6, is equal to minus 5x plus 2x, which is negative 3x. And that implies that x is equal to minus 2. 6 over negative 3 is minus 2. That was already a solution. Okay, so that was already a solution that we found. And so that's going to be a solution to the problem, and that's the end of the problem. That basically this solution solved for x is equal to minus 2. All right, so that's that's the problem. It's a little bit more intricate than the ones we just considered, but it goes to show you that the same processes apply. You just have to think things through. And another exercise to think about is, why is it the case that we got the -2 back again? Maybe try to think about, is that a coincidence, or is that like specific to this problem, or is there some deeper reason why that happened? And leave a comment down below. I'm happy to engage with that, and that's a question for you. What do you think? Alright, so that's this video on solving elementary equations with absolute value. It should give you a fundamental basis. So basically, you have more and more complicated equations that are out there with absolute value, but the basic principles always apply. And if you just keep those in mind, you can approach anything. And I may do future videos on this as well. So if you love this video, please leave a like and subscribe. It would mean a lot to me. The great thing about YouTube is that these videos are free, and my goal is to create free, accessible math education worldwide to as many people as possible, to inspire them. And I really would mean a lot if you liked and subscribed, because then it would disseminate to more people and the process would continue. And of course, if you have comments, please leave them down below. I'll read all of them, and I will respond to as many as possible. I hope you have a wonderful day. It meant a lot to make this video, and I wish you all the best wherever you are, whatever time it is. Have a good day, evening, night, and I'm super excited to see you in the next video. Thank you so much.